Hey guys, RickGamer34 here. This is going to be CPU tutorial part 5. And in this tutorial, we're going to be going over how to start building our execution unit with the instructions that we have planned out over there. So what we're going to need to do, and if Ted would help, is our lines that we have our decoders with, or our decoders, what the hell am I talking about? That we have our things like flood carry and if zero and all that kind of stuff. There's got to be a better way to do this. Yeah, I'm going to get rid of that, and I'll just remember I have to add a tick to that line.
What the hell are you doing?
I'm just trying to get this perfect.
You're making it look messy.
I'm trying to make it work. Okay, and we need this repeater there. That's just for syncing. Then we also need... That is our carry-in, right, Ted?
Yeah.
So, Ted, if you could bust the carry-in there. Then we're going to need... This is flood carry, so flood carry will go next to that. There goes flood carry. Then we need our ore, which is right here.
Oh, wait, I have to fix this. You just made everything rigged. Or actually, I did, kind of. Oh, wait.
What are you doing?
Everything. Trying to make busing easier.
Also, we're going to add a repeater here for everything, so... And the reason this one has 2 repeaters is because there was a repeater going into this, so this just needs to be timed with the same as this. Yeah, it's synced, so that's supposed to be like that. This last line has to go to our shifter, and here is the shifter.
How are we doing our flags?
I'll go over that, but first we're going to do our instructions. So now let's test. I need a redstone block. Now let's test for everything reaching. That reaches, that reaches, that reaches down here, that reaches there. This one does not quite reach, so we'll just add a repeater. And then... Are you kidding me? This one needs 1 signal strength, so all we'll do is we'll just do that. And now that reaches.
It works.
So everything reaches. Now what we have to do is, if Ted, would you go ahead and expand this line, however many other lines we have. Stack it 5 times. Or yeah, do that. Do it out, like, we have quite a bit of things to decode. Do it 16.
There.
Wait, hold on. Now stack. Okay. Make sure you get this. Oh, okay.
That's only 8.
Yeah, but we're gonna have more than 8, but we'll start. Okay, so
how many operations?
We
15?
have, hold on, let me think. We have 1, no.
You have no
1, 2, 3, 4, 5, 6, 7.
Look at the last
8. We have 8. So yeah, that's good. Okay, so the first one is going to be subtraction. So how does subtraction work? Well, we're going to end up... Well, actually, let's label all this crap.
Invert A carrion. Spoiler.
Yeah. Thanks, Ted. Alright, now let's just label... Oh, whoops. The signs what this is. So if you hook this up the same way as me, this bottom one here is invert B, and the little exclamation mark stands for invert. So and then this one's invert A. Bottom. This one is carrion. This next one is flood carry. Oh, that works too. Can you change that to actually black compressed coal?
Okay.
And we have our ore. And we have our shift. Thank you. It just looks nicer in OCD. So those are our commands. So now if we want to do subtraction, we do invert B, which is right here, and we do carrion, which is right there. So what's our next opcode down here after subtraction? It goes OR, then NOR. Okay. Excuse me. So OR is pretty basic. We go here and do OR. And if we want to do NOR, we do OR with flood carry. And that's how we get NOR. So next line is going to be and also we have to do NAND after that. So AND is invert A, invert B. So invert A, invert B. We're going to have to do OR, which is this one. And then to get it to be AND, we also have to do flood carry. So there's that. Now if we want just NAND, we're going to do that without the flood carry. That's how we get NAND. Then if we do XOR and XNOR, basically XOR is flood carry and invert B, or flood carry and invert A, it doesn't really matter. So flood and invert, and then just flood carry for, oh, I guess Ted's going to be gone for a little bit. This right here is just XNOR. And if we just, the last one is shift, and that's our shift function. So basically now if we unpower this, this ROM tells it, oh, this is subtraction. Let me just get rid of this. So let's label. We have sub or nor and NAND XOR XNOR, and we have shift. Whoops. Like so. Alright guys, so now we have to build our decoders for our registers. So if you have these kind of registers, it's kind of simple. So we'll start with the write. So basically we're going to come up like so. And that should leave us, nope, we're going to come up, what am I doing? We're going to come up to about here. And let me just double check to make sure that we'll have enough room for this one here. Yep, we'll have room. Okay. So now what we need to do is build our decoder. So Ted, can you come up here and help me out? You left the game, Ted.
That's because, an error. I crashed.
Oh, did you?
Yeah. I was trying to make a map of this plot.
Okay. So this decoder is going to be our write decoder. So in our instruction set, it'll be the lime green. Ted, can you teleport?
1 second. TP. Alright. Hi.
Hi, Ted.
Wait, what did I need to do? I'm kind of out of it today.
Basically just bust what I've been doing, and I'll place redstone.
Whoa. I had to change my FOV.
What's it at?
1 second.
I don't worry
Normal?
about it, Ted.
No.
What did you play at 77?
Quake Pro.
No way.
I'm like on. I did /fast, and I'm on Quake Pro.
So it needs to be extended to at least. It needs to be extended 2 blocks, Ted.
Okay.
You have like 6 blocks.
It's 2 blocks.
Okay. And then I'll place this on top. So this is going to be the value that's going in to tell it where to decode to.
Okay.
Now it's important when you're building decoders to make sure that your reads and write decoders are all decoded to the same address. What the hell? Did you really just drink milk?
Well, as the Quake Pro and the /fast, it's kind of doesn't match.
Okay.
Well, you should try it.
No, not right now.
Because this is like doing math.
Hold on. Boom. What? Ted, I'm overlaying redstone.
Oh.
Alright. So, we're going to count up basically. So 1, 2, 3, 4, 5, whoops, 6. Why did I build 4? Wow. We only have 3. I forgot. We didn't need to extend it. We only have 7 registers. So now what we have to do is place a repeater where there isn't a torch going in. So this requires no overhead anything. We just basically have to just do this. If it stop falling. So a repeater has to go here, and a repeater has to go here. And don't put any ticks on the repeaters either. We want this to be a perfectly synced 1-tick decoder.
Yeah.
Yeah. And we'll just end up copying and pasting this one in. For those of you that don't have World Edit, A, that sucks, B, you should get it, and C, you can do it by hand. The concept is pretty simple. It's just a way of... It's just like a bunch of implies gates put together.
A implies B.
Basically.
Wait, what was I supposed to be doing?
Just copy, Ted, copy from here and from here.
Oh.
Now select, wait, I'll tell you where to copy exactly quick.
Like, where do I paste it to?
Copy right here, copy right here, copy from where I'm standing. And then paste it to right here. Paste -A. Perfect.
I was about to do stack minus A.
I would have cried. I would have cried. Actually, no. No, it wouldn't have been that bad, I guess. Okay, and then we have to do our one last one. You can paste it here. Paste here, minus A. Do you see
Wait,
what
I
I'm
have to get over to you, because I can.
Oh, okay. So now we have our 3 decoders set up. So let's say I want to write to address number 1. Turns off that one and only that one. If I want to write to address number 2, goes like that. 3 goes to the next one. 4, 5, 6. Whoa, 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 whoa. 6 doesn't work. Oh, signal strength. Duh. Okay. So now basically what we have to do is sync this. The best way to do this is... There's no way to get these perfectly synced, is there? Let's see. Oh, we can do it like this. For this one, I guess. No, I don't like that. I don't like that at all. Oh. Right, this is going to take a little bit of redesigning. But it's possible to do still, so... Place a repeater there. And we can do the same thing here. So Ted, can you recopy this and paste it in a second? Alright, Ted, you there? Ted! Nope, okay, he probably went somewhere. I don't know, he just disappears sometimes. Doesn't tell me, ever. Okay, so now we have to sync our decoder, so add an extra tick here, 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 and here. And that makes sure that is perfectly synced. So now let's just fix that on the same this down here. Alright, so this is where the repeaters are going to go right here. And that means we have to hook these up another way. Sorry about that, Bandicam stopped again. So, come here. And then it requires one here, so we'll do the same thing. And there. And now we have to sync, so that one. Alright, so add a tick here, add a tick there, add a tick there, and add a tick there. And then, so you should have 3, 3, 2, 2, 1, 1, 1, 1. Yeah, like so. And just replace these. And yes, the last one's supposed to be off because 7 was inputted. And yes, these are supposed to be inverted like that. That's how it's supposed to be done. And then, so we just have our last one. Put the number 7. Here, here. Ted, are you back? Oh, welcome back, Ted.
Hello, sir. What time is it?
I'm in the middle of recording still, Ted.
Oh, sorry guys. I must have been accidentally resting my eyes.
I hate you so much, Ted. I'm just
Okay.
fixing these decoders to make them synced right now, Ted, if you were wondering.
Oh. Okay.
Oh, okay, that's all you have to say? Is there anything you'd like to share with us, Ted, about today?
That I did nothing.
Why are you so tired?
Because I've been, like, doing stuff the whole week.
Ah. And then now let's just like that, and we have to sync this, so add a tick, add a tick, add a tick, and add a tick, and now everything is synced perfectly. And yes, these are supposed to be, if you copy this schematic, the schematic of the registers were completely synced, so now we're just, as we're building the decoders, we're syncing. And this is basically the execution unit. Alright guys, so back to the instruction set. I forgot to note that the load data from memory and store data to memory have to use the immediate as a address of where to store. So this is going to be called the data address. Alright guys, so we're going to start actually turning this into a CPU. This is of the finished execution unit basically, so now I'll get rid of this. We're going to come to this input of our computer, of our execution unit, and we're actually going to come straight to this one right here. And straight to this one. That one comes up one. So yeah, basically we're trying to meet halfway here to save busing time. So I guess, well, that was kind of pointless, yeah. Like so. Oh, still pointless at this time. Okay.
Oh yeah.
What?
What am I supposed to be doing?
Add redstone to those lines right there, would you?
Okay.
I'm gonna do a spiral.
Do I need to block this off here?
Yes.
Yay. I just made an OR gate.
What?
Just made an OR gate.
That's fantastic.
It is. You should be very proud of me.
I should. Because for some reason I'm not.
You fucked this up hardcore.
And when don't I? I just wanted to make it, like, come out the least amount as possible. Actually, Ted, I guess it really doesn't matter if you block it off or not, but I mean, might as well. Alright, did you place redstone? Okay. Now, we're gonna have to
switch messages.
What are you doing?
What? I'm fixing what you messed up with.
It was fine, but whatever.
It was not, I swear to God.
Whatever. So we're gonna need, repeaters like that. And we're gonna need to make an AND gate, and we're gonna do the fastest AND gate possible without pistons. It's basically a 1 tick throughput AND gate, but it also takes 1 tick to toggle. We'll do that. Now this is a pretty advanced computer if it's your first time building a computer, so if you don't know what's going on, this is one toggle of the immediate. The immediate's going to be able to do 4 different things by nature. It's going to be able to input raw data into the ALU. It's going to be able to do 3 different addressing types. Alright, so now what we have to do is just copy this design that we have here. And copy from the output of the computer. And come down here to about right here. Do paste -a. Whoops, what I messed up. Let me try this again. Oh, -a. For some reason it didn't paste. Okay, let's try to recopy it. Oh, I know what I did wrong. There. And copy from here. Paste -a. There we go. So we have one here, and this is going to be for our RAM addresses, and it will eventually be hooked up to here.